All right, so this is for those of you that were absent today. If you complete these problems along with me in your packet, that will help catch you up in math. So today what we did is we kind of took what we did previously a step further. So the last couple lessons, remote and in class, we practiced writing expressions, one-step expressions and two-step expressions using variables. So today we're going to do the same thing. We're going to write a let statement, we're going to write an expression, and then sometimes we're going to evaluate it if we have a number. So this is kind of like translating. We're taking a little situation here and we're writing it using math. We're going to use numbers, we're going to use symbols, we're going to use variables, and then we're going to see if we can evaluate it if we have enough information. So for example, on page 21, or on the top of page 21, it says Tim has 10 less than 3 times as many lawn gnomes as his neighbor Gord. Write an expression to represent the total number of lawn gnomes Tim has. So here's the key phrase we're looking at here. Tim has 10 less than 3 times as many lawn gnomes as his neighbor Gord. Hopefully they're friends. So we got to think, what do we not know? Well, we don't know how many lawn gnomes Gord has. Okay, we don't know how many. If we knew how many lawn gnomes Gord has, we can figure out how many Tim has, but we don't. We don't know that information. So we're going to write a let statement. Let G equal number of lawn gnomes, with a silent G, of course, Gord has. So Gord has 3 times as many and then 10 less. So that times, again, is going to be multiplication. 10 less is going to be subtraction. So we're going to start with the times. We're going to start with the multiplication. So he has 10 less than 3 times. Well, here's 3 times. 3 times G. That's 3 times as many lawn gnomes. But he has 10 less than that. So then to show 10 less, we're going to subtract 10. 3G minus 10. Now, if we never knew how many lawn gnomes Gord has, we would not be able to find out the total number that Tim has, because that's a variable. We don't know the number. However, if you look at this last column here that we'll look at the end, it says evaluate if Gord has 6 lawn gnomes. All right, so then we're going to use our expression to see how many Tim would have if Gord has 6. So we're going to write this expression, 3 times G minus 10. G is 6 because that's how many lawn gnomes Gord has. So it'd be 3 times 6 minus 10. Well, what would we do first? Parentheses, no. Powers and roots, no. Multiplication and division from left to right. We're going to do the multiplication first. 3 times 6 is 18 minus 10 would be 8. So this would be the answer. Now, we were only able to, again, to get a single number answer because we knew at the last step how many lawn gnomes Gord has. All right, let's try another one here. 8 friends went to Darien Lake. Each person bought a ticket for N dollars. 5 of the friends also bought a giant gummy bear for $6. Write and simplify an expression to represent the total amount of money the friends spent. Okay, so we have 8 people going to Darien Lake. Each person bought a ticket for N dollars. Well, they actually give us the variable here. That's kind of nice. We still have to write a let statement, but we already know what the variable is. It's N. So we're going to let N, and what does N equal? It says each person bought a ticket for N dollars. That's how much the ticket is. That's the cost of the ticket. So we're going to let N equal cost of ticket. All right, 8 friends went to Darien Lake. Each person bought a ticket for N dollars. That means there were 8 tickets that were purchased. So each ticket is N. 8 tickets would be 8 times N. But that's not all they bought. 5 of the friends also bought a giant gummy bear. So that's how much they spent in tickets, plus 5 of the friends bought a giant gummy bear for $6. So 5 people times 6 would tell us how much they spent on giant gummy bears. It's quite a lot. All right. So right now, this expression looks good, but we can actually simplify this because we can do 5 times 6. So it would wind up being 8 times n plus 30. That would be our final expression. That's called simplifying. When we can actually do the math here, we can simplify it. So our expression is 8n plus 30. 8 people bought a ticket for n dollars, plus they spent $30 on the giant gummy bear. Oh, now we can evaluate it. Because they gave us a number here for the ticket, we can actually find the total cost of what they spent. Because instead of n, we can do 8. So I'm going to write the expression, 8 times n plus 30. 8 is the cost of the ticket, so it's going to be 8 times 8 plus 30. Well, we do the multiplication before addition. 8 times 8, 64, plus 30. Then we do the addition here. 64 plus 30 would be $96. So a lot of that money was spent on the giant gummy bear. So hopefully that giant gummy bear was worth it. It probably was. All right. Let's take a look at this example. It says, a sporting goods store was selling a pack of 9 baseballs and 2 bats together. Each baseball costs B dollars and each bat was T dollars. Write and simplify an expression to represent the cost of 7 of these packs. Well, this is a tough one. All right. So first thing I notice is that there are 2 variables here. There's B, they give us B, and they give us T. Each baseball cost B dollars and each bat was T dollars. So we're going to have to write 2 let statements because we have 2 variables. B is the cost of a baseball. Cost of baseball. T, each bat was T dollars. That's the cost of the bat, was T. So we have 2 variables here. Let T equal cost of a bat. All right. In each pack, there were 9 baseballs and 2 bats. So this person, you would be able to buy 9 baseballs. The cost of them is B. So to find the cost of the baseballs, it would be 9 times B. So if like the baseballs were $2, you would do 9 times 2 to find the total cost. So we don't know what the cost of the baseball is. It's B. So we'd have to do 9 times B to find the cost of the baseballs. Plus, each pack had 2 bats. Each bat cost T dollars. So to find the cost of the bats, you do 2 times T. Now, that's 1 pack. That's 1 of them. However, we want to find the cost of 7 of these. But here's the thing. When we use parentheses, we can show groups. We want to show 7 groups of this. So if I put this in parentheses, that's like grouping the pack together. To find the cost of 7 of them, I'm going to put the 7 outside the parentheses. That's like saying 7 groups, because parentheses are like groups, 7 groups of 9B plus 2T. So again, inside the parentheses is the cost of 1. If you knew B and you knew T, you could multiply them and add them together to get the cost of the whole pack. Then, if you multiply that whole thing by 7, you get the cost of 7 of them. So that's when parentheses can help. Parentheses oftentimes will show groups. So you'll be seeing this a few more times in the unit, using parentheses to show groups. Actually, we'll be seeing it in this next one. So we got a group of 5 people went to Disney World. Again, when I see that word group, I'm thinking I might have to use parentheses when we're thinking about a group or a pack or a collection of something. Each person got a ticket for $8 and bought 3 turkey legs, which are a popular item at Disney World. Define a variable and write an expression to show how much the group spent. So what do we not know? They don't give us the variable for this one. Like in the previous 2, they gave us the variable or the letter. So we have to find out what we don't know. Each ticket's $8. We know that. We know 5 people are going. They bought 3 turkey legs. Well, we don't know the cost of the turkey leg, so that's going to be our variable. So we're going to let, I don't know, W equal cost of turkey leg. Okay. So a group of 5 people went, and each person got the same thing. Each person got a ticket for $8. $8 was the ticket. And they bought 3 turkey legs each, which seems like a lot. So to find the total cost of the turkey legs, you would do 3 times W, because that's the price of the turkey leg. We wouldn't have to multiply the 8 by anything because we know the cost, and each person is only buying 1 ticket. But this is the cost for one person. 5 people went, a group of 5. So to show that, we're going to use parentheses. So there's the group. We have 5 groups of this. 5 groups of a ticket and 3 turkey legs. So again, that's when parentheses can come in handy to show a group. All right, so now we can evaluate it because we do know the cost of the turkey leg. Turkey leg was $5.50, which seems reasonable. It's probably a little bit more than that in real life. But first thing I'm going to do is write down the expression. We now know W. W is $5.50. So in my next step, we're going to substitute in the number. I'm going to be careful with my dot because it looks like a decimal point. First thing we do is parentheses. We're going to look in the parentheses. We have adding and multiplication. We're going to do the multiplication first. 3 times 5. Well, I'm just going to do this off to the side. 3 times 5.50. It's going to be a bit above $15 because 3 times 5 would be 15. It would be $16.50. $16.50. Okay, so again, we still have to do what's inside the parentheses. We can add this. Now, when we add $8 and $16.50, we have to make sure to line up the decimal points because we wouldn't put the 8 below the 0 because that's not 8 cents, it's $8, so we'd have to annex 2 zeros there. And you get $24.50. 5 times $24.50. Last thing we'd have to do is, on this one's a few steps that we have to take here. If we multiply $24.50, which is the cost of each person, by 5, that will give us the total cost of all 5 people. 5 times 4 is 20, plus 2 is 22. 5 times 2 is 10, plus 2 is 12. $122.50. Which, I mean, Disney's expensive, so got to kind of expect those higher prices. But yeah, that was a little tougher because there was a decimal in there. But again, we use parentheses to show groups. We use variables to show numbers we didn't know. We're writing expressions, and then sometimes we're evaluating them if we have the right numbers. All right, let's check out some of these on the back here. If you want to try some of these on your own, feel free. And then you can check with me when you finish. A kangaroo jumps 4 more than 3 times the distance that a tree frog can jump. Write and evaluate an expression to represent the distance a kangaroo can jump. Well, what do we not know? We don't know how far the tree frog can jump. So we're going to let D equal the distance tree frog can jump. A kangaroo jumps 4 feet more. It should be 4 feet more than 3 times the distance. So times is going to be multiplication. More is going to be add. 4 feet more is going to be adding. So we're going to multiply first. So it's going to be 3 times D. Then we have to add on that 4 at the end because it's 3 times more and then 4 more than that. So 3D plus 4. Now again, if we didn't know what the D stood for, we couldn't evaluate it. But it says here, evaluate if a tree frog can jump 7 feet. All right, let's do it. So we're going to rewrite the expression. Instead of D, we're going to put 7 because that's the distance a tree frog can jump. Plus 4. We do the multiplication before the addition. That's 21 plus 4, which is 25 feet. Nice. So that's how far the kangaroo can jump. If the tree frog can jump 7 feet, the kangaroo can jump 3 times more than that, which would be 21, and then 4 additional feet. So it'd be 25 feet. Nice job, kangaroo. That's a lot of feet. That's a lot of feet there. All right. For 9 weeks in the summer, Julie mowed the lawn every day for m minutes. Well, there's our variable right there. So we're going to let m equal mow the lawn every day for n minutes. Number of minutes Julie mowed a lawn. So this is per lawn. Each lawn took n minutes. For 9 weeks in the summer, Julie mowed the lawn every day for n minutes. During 4 of these weeks, she also cleaned her parents' car. Yikes. Which took her 15 minutes each time. Write and simplify an expression to represent how much time Julie spent doing chores for those 9 weeks. Now, for 9 weeks in the summer, Julie mowed the lawn every day for m minutes. Should be every week. Should be every week, because that'd be extreme if she did it every day. Every week for m minutes. So 9 weeks, m minutes per week. So 9 times m would be how much time she mowed the lawn in total. She mows the lawn for 9 weeks, m minutes a week. Now, but 4 of those weeks, she cleaned the car for 15 minutes each time. So 4 times she cleaned the car, which took 15 minutes. 9 weeks, m minutes per week for mowing the lawn. 4 times 15 will give you how much time she spent cleaning the car. Now we can simplify this a little bit because we can multiply that. 4 times 15. 4 times 15 would be 60. So there's our expression, 9m plus 60. Now, if we didn't know what m was, we couldn't evaluate it, but we can because it says it takes 25 minutes to mow. So 9 times m plus 60 is our expression. It'd be 9 times 25 plus 60. Now, 9 times 25 is like 9 quarters. 8 quarters is $2, 200. 9 quarters would be 225 plus 60. 225 plus 60 is 285 minutes. Wow. But that's over 9 weeks. That's like 2 months of work. So she's not doing that all in one day, that would be a bit extreme. That would be a bit much. All right, just a couple more here. It says to compete with Arby's Extreme Combo, which I believe was perhaps mentioned on a different page, Wendy's came out with a combo of their own called the Intensity Meal. That's interesting. In the Intensity Meal, you get 5 burgers, where each burger costs $B, and 7 large fries, where each container of fries costs F dollars. Write an expression to represent the cost of 9 Intensity Meals. Now, not just buying one, we're buying 9 of them. All right, so we got 2 variables. We got B and we got F. So we're going to let B equal, it says, each burger costs $B. That's the cost of a burger. And then each container of fries is F dollars. So this is cost of fries. All right, so in this meal, you get 5 burgers. Each one costs B. So that'd be 5 times B would get you the cost of the burgers, plus 7 large fries. They each cost F dollars. So that'd be 7 times F. Now that's one of them. You get 5 burgers, B dollars, 7 fries for F dollars. That would be one, just one. But this person is buying 9. So to show 9 groups, we're going to show groups using parentheses. We're going to buy 9 of these. So we're going to put it in groups, in a group, and we're going to have 9 groups of 5 burgers plus 7 fries. That's going to be our expression. Now we can't do anything else with that because we don't know how much a burger costs, and we don't know how much the fries cost. So that's it. We can't evaluate that, unfortunately. Would love to find out how much that costs, though. All right, last one. Last one we're going to do here. A family bought 100 little bags of Doritos, like those little ones. Each day, they ate a certain number of bags. Write and evaluate an expression to represent the number of bags they had left after 12 days. Okay. Now, this is a toughie. What do we not know? It says each day they ate a certain number of bags. We don't know how many bags they ate per day. So we're going to let D equal number of bags they ate each day. Okay. Writing this expression is a little tough because to find how many bags of Doritos they ate D per day for 12 days. So let's say this number was like 4. If they ate 4 a day for 12 days, they would have done 4 times 12 is 48. So if we did 12 times D, that will tell us how many bags they ate. But we're not trying to find how many bags they ate. We're trying to find how many bags they had left. They started with 100. And each day they ate a certain number. So we're because they're eating them, it's like they're subtracting them. So we're either going to subtract 100 or we're going to have 100 in front. The thing is, they start with 100. And then each day they eat a little bit more. So let's see if this makes sense. Let's say they ate 2 per day. 2 times 12 is 24. 100 minus 24, that would tell us how many they had left. If we did the reverse, we'd have 24 minus 100, which would be a negative number. We couldn't have that. So I think this is right. They started with 100 bags, and you subtracted because they ate 12 bags, or for 12 days they ate a certain number of bags. So that's going to be the expression. Can't do anything more with that. But it says evaluate if they ate 6 bags a day. Well, then we're going to write the expression. Instead of D, we're going to put 6 because that's how many they ate per day. We'll do the multiplication first. 100 what's 12 times 6? Would be 72. And then 100 minus 72 would be 28. Oh boy, 28 bags left after 12 days. So I guess they could keep eating 6 a day for another 4 days, but then they would only have 2 left and then kind of run out from there. All right, so I mean, this is a tough skill, being able to write an expression from a situation like this. But we're writing let statements. Sometimes we use parentheses to show groups. But the next remote lesson we'll have you practice this more with me as well. So if you have any questions while you're working on this, let me know. But I hope to see you soon. All right, bye-bye.